Welcome back to a new machine learning tutorial. In this video, we are going to talk about polynomial regression. We are going to talk about the logic behind that, and we are going to code it using Python scikit-learn. Let's start coding. I'm in VS Code interface right now. I'm going to be using this code editor in this tutorial. You can use anything that you want, completely up to you. I will say polynomial regression.ipmb. I'm going to go with Jupyter Notebook for this tutorial. I'm going to select my kernel as 3.11.4. Then I will say polynomial regression, and let's talk about the concept. Polynomial regression is an extension of linear regression that models the relationship between the independent variable x and the dependent variable y as an nth degree of polynomial. So we can write the important things. Unlike linear regression, which fits a straight line to the data, polynomial regression can fit a curve, making it suitable for data with non-linear relationship. And in real world, we don't have linear relationships in all of the data. So let's talk about the mathematics behind that. So let's firstly write the formula of the linear regression. So we have a beta 0 and beta 1. These are our coefficients, and we got an error term. So this is our linear regression formula. In polynomial regression, we extend this to model to include powers of the input features. Like we are going to say y is going to be equal to the beta 0. We have no coefficients on this side, and beta 1, x1, we can directly type x. Then we are going to have beta 2, and now we have the x with the degree 2. So we are going to have beta 3, x degree 3, and we got the powers like this. And at the end, we are going to have the beta n with the nth degree. And we are going to have the error term still. So betas in here are the coefficients. Also, we can refer them as weights, and x's in here are input features that we are going to give to our model. You can see this x's, and this e represents the error term. So this model allows for the fitting of the nonlinear relationships by transforming the features into polynomial terms. So let's start coding it. What I'm going to do firstly is I'm going to import numpy as np. Then I'm going to import matplotlib.pyplot as plt, because I'm about to plot the data that I will create right now. Scikit-learn.datasets import make regression. We are going to work with a scikit-learn created dataset. I'm not sure what's wrong. It's going to be datasets. Okay. Now our imports are ready. Let's create our data. So I will say in the new cell x and y, I will use make regression for the data creation. Number of samples, let's use 1000. Number of features, 1. And I'm going to add a noise such as 10. So now we have the x vector in here and y vector in here, which is going to be our target. And now for making a polynomial relationship, I'm going to set the y plus 50 multiplied by x dot flatten, and I'm going to take the power of 2 like this. So I'm going to call the new y. We are going to have this vector. I'm just going to create a quick scatter plot for seeing our relationship x, y. We can give the color of blue like this, and I can give it an x label like feature and y label like target, and we can use plt.show. So this is how our data looks like. So we created the quadratic relationship using this equation. Great. Now we can create a polynomial regression model. I'm going to firstly show you how we can create a polynomial using a fixed polynomial degree, and then I'm going to show you how we can try out multiple degrees and find the best performing one. So first we will say from scikit-learn that preprocessing import polynomial features, and then we will say from scikit-learn.linear model import linear regression. Next up we will say from scikit-learn.pipeline import make pipeline, and lastly for the model evaluation we will say from scikit-learn.matrix import r-squared score. And I'm going to be talking about what is the r-squared in a second when we train and evaluate the result. So I will say polynomial features, and it's going to be equal to the polynomial features. I'm going to set the degree as 2 and include bias as false. Next, I will say model is going to be make pipeline. We will say polynomial features, then we will say linear regression in this order. Next up, we will say model.fit, and we will pass our x and y in here. And we have our pipeline model ready right now. So we can make predictions with it right now. We can say model predict and we can give x. Now we have this kind of values. As you can see, we make predictions with the model, and let's store them in something like y predictions. Next up, we can get the r-squared score. Using this, we will give the first true y values and the predicted ones from the model we create, and it's 0.97. So this means that 97% of the variance in the dependent variable, which is y, can be explained by the independent variable in our model, which is x. In other words, our model explains 97% of the variability in the data, which suggests an excellent fit because r-squared can take values between 0 and 1, and values closer to the 1 is better in terms of r-squared score. So now let's try different degrees and how we can get the r-squared scores for the different degree values. By the way, you can try out different degrees, like you can try 20 instead of 2 in here, and if 20 performs better on the dataset, then you can use 20 for the predicting unseen data. So we will say degrees, it's going to be equal to the 1, 2, 3, 5, 10, 20, and let's add 50 for example. And I will say for degree in degrees, I'm going to say polynomial features. So it's a loop, so it's going to go for all of the polynomial features one by one. When we create a loop like this, I will say degree is going to be degree, the thing in here. If you are using another thing, just pass the word after the for. Then I will say include bias, false. Next up, I'm going to say model is going to be make pipeline, polynomial features, then linear regression in here. Okay, we have that ready right now. Next up, we will say model.fit. We will give x and y. We are going to say y prediction is going to be model.predict x, and r-squared is going to be r-squared score, y and y prediction. And now I'm going to write a print statement like print r-squared score for degree, and I'm going to give the degree in here, polynomial regression, and we will give like r-squared, but let's give it in a good way like this. So I'm going to make this run right now, and here we get our r-squared scores, and we see that the best performing ones, which means the values closer to 1, is 10 and 20. So if we are going to create a polynomial model for predicting the unseen values, we need to go for 10 or 20 in this loop. By the way, you can just change this list, like we have 10, 20 in here. I'm going to delete the others. I will say 11, 12, 13, 14, 15, and we can extend this list in this order, 9, and let's try this one out. Let's see if we can find a better one. No, this is the maximum r-squared we can get. Great. So after finding this degree, you can create a model just like in here by setting the degree to the best one in here. In here we will take 6. So you can just set the degree as 6 and then make predictions using this method. So let's summarize what we did in this video. We started with talking about polynomial regression, and we take a look at the linear regression formula, then the polynomial regression formula in here. Then we create the dataset using make regression, and we make it a little bit like suitable for the polynomial regression in this way, and we plotted our data in here. Next up, we create our polynomial features in here with the degree of 2, and we create the pipeline. We trained our model and make predictions, stored them in the y predictions, then we get the r-squared score on this. I explained the concept of r-squared, which we can summarize like 1 is the best score and the values closer to 1 is automatically meaning that better model. But that could be overfitting if the value is too high, if it's not tested, but it's not the topic of this video. So Then we created degrees in a list format, and we make a for loop in here for trying out different degrees. And now we can just take the degree, the best one in here, like this, and create our model in here using this degree, and we can make predictions with it. That's it for this tutorial. Thanks for watching. Thanks for watching this video on polynomial regression. I'm sharing machine learning tutorials in a playlist. I have a playlist named Machine Learning Tutorials where I have more than 40 videos just like this one. You can reach that playlist from the cards of this video or from the description. I'm sharing new data science videos every week on my channel. You can subscribe for more videos like this. Have a great day.